Hi, this is Adrian from Live to Learn Academy, and welcome back to our channel where we go through the Nelson Advanced Functions textbook. Today we'll be going over lesson 3.6, Factoring Polynomials. Now, for those of you guys who are not subscribed to the channel, feel free to subscribe to the channel as we post daily content like this, which literally goes through the whole Advanced Functions textbook to help you along your journey through the course. If you are somebody who needs tutoring, feel free to click the link in our description below where you can get in contact with our team to help you ace this course. But without further ado, let's get straight into it. Okay, chapter 3.6, we're talking about factoring polynomials. There's two main concepts you need to know. Okay, so here are the two main concepts. The first concept is called factor theorem. And the second concept is called remainder theorem. Okay, now these are very useful tools. These are actually tools that we're going to be using throughout the course. Now, each of these tools, factor theorem and remainder theorem, they both have a significant purpose. Factor theorem is used when you want to determine if something is a factor. So when you want to determine if something is a factor, right? And I'm going to highlight this key word, if something is a factor, then you would use this thing called factor theorem. Remainder theorem, on the other hand, is, I'm going to just copy this real quick, is when you want to determine the remainder. So factor theorem, you're determining if something is a factor. Remainder theorem is when you want to actually determine what the remainder is. It's used to determine the remainder. Okay? So we're going to go through some questions. So the main kind of concept is this. If you have a factor, so let's start with factor theorem. So now that we got the definitions out of the way, let's go through some questions with regards to factor theorem. Let's say you had a function, let's say the question will ask you, determine if x minus 1 is a factor of the function okay. Let's say the question is asking me to determine if x minus 1 is a factor of this. The way I would do that is I would actually take this number, x minus 1, set it to 0, and I have x equals 1. And then what I'm going to do is I'm going to say, okay, f at that number if this equals 0, and this is, so if this is true, then I know it's a factor. So I actually have to do out the math. So let's do out the math really quickly. 2 times 1 squared is just 2, plus 3 plus 1, which is 6 equals 0. So I'm testing if this factor is a factor by putting in the function and seeing if it equals 0. If it equals 0, that means there's no remainder. Therefore, it's a factor. So this is another thing we need to know. If there is no remainder, then it is a factor. So if we get it to equal 0, so f at that function, if it equals 0, it is a factor. Okay? So look carefully. We're given a factor and we're asked to determine if it is a factor of the function. If it equals 0, it's a factor. In this case, it didn't equal 0 because 6 does not equal 0. Now here's the thing. If it doesn't equal 0, then 6 is the remainder. So this is really important. If it equals 0, boom, we know it's a factor. If it doesn't equal 0, then we know that number, 6, is the remainder. So this is where a lot of people, get kind of confused. It's not that hard of a concept, but a lot of people get confused with this. So factor theorem, you're essentially doing that. So let's look at its counterpart, remainder theorem. So what does remainder theorem state? Remainder theorem is let's look at the definition. It's when you want to determine the remainder. So let's say it gave you a function and it said, state the remainder if x plus 2 is divided by, let's say, the function x squared plus 7x plus 9. So there's two ways we could do this. One way we can do it is we can go the long division. We can do long division with these two terms, the dividend and the divisor, or synthetic division. And we can actually just manually do this. So this is like a manual process. Okay? So we can go that route. But the good thing about remainder theorem, because remember, when we do long division and synthetic division, it gives us everything. It'll give us the dividend, it'll give us the divisor, it'll give us the quotient, and it'll give us the remainder. So if we want everything, we're probably going to have to do the manual process. But certain questions are not going to ask you for everything. They're going to ask you for a specific thing. So remainder theorem, it literally baits you into asking you questions that are just asking about the remainder. If you notice, it says state the remainder. It doesn't care about the quotient. It doesn't care about anything else. If you're just asked for the remainder, this question becomes even easier. And this is why remainder theorem comes clutch. Okay, remainder theorem. Let's look at this. X plus 2. So that means if this is x plus 2, we're going to say x plus 2 equals 0. X is equal to negative 2. Okay? And then what we're going to do is we're going to put f at negative 2 in the function x squared plus 7x plus 9. So what is that going to be equal to? And whatever the answer is going, if it equals 0, then it's a factor, which means that there is no remainder, right? When something is a factor, we know by default there is no remainder because it equals 0. But if we get a number that's not 0, then we know that's the remainder. So let's look at this. Negative 2 squared plus 7 times negative 2 plus 9. So negative 2 squared is 4 minus 14 plus 9. So you got negative 10 plus 9, which is negative 10 plus 9. What is that? Negative 1. So you notice how it's not 0. So we got negative 1. Therefore, this is the remainder. Okay? So remainder theorem is literally for just asking what the remainder is. Let's say on a test you completely forgot what remainder theorem is. You can always just do the manual process of long division and synthetic division, and you can get the remainder manually. But you're going to need to know how to use remainder theorem for other questions in the test. We'll get to those other questions later, but remainder theorem is a very important concept you're going to want to know. So all in all, what are you doing, right? So just a recap. If you have a function x minus a, let's say this is a factor, okay? If I set this to 0, it's going to be x equals a. And then now, if I plug in f at a into whatever the function is, and I get 0, then it's a factor. If I get a number that's not equal to 0, then it's a remainder. So equaling 0 is factor theorem, not equaling 0 is remainder theorem. So I hope this video really encompasses, these two concepts. A lot of people confuse them, but it's not really that hard once you start practicing. If this is something that you need tutoring with, or you're struggling in the course, feel free to click our description below. You can get in contact with our tutoring team and they would be happy to help you guys out. But without further ado, I'll see you guys in the next video.